So Rohit has a reasonable amount of experience working with blockchain and cryptography. So today's talk will be based on blockchain.
So I'll be talking about blockchain today. Blockchain is a distributed ledger which is immutable, tamper-proof. It is decentralized because it disintermediates all the third parties which are involved in the system, and it is trustless. By trustless, I mean that there is no need of trust in the system. The system is built and the organization is such that there is no need of trust. It doesn't mean that there is no trust in the system. So some prerequisites, hashes. So what are hashes? Basically, they are the functions which take input string of any size and give an output of a fixed length. These are called hashes. So whether you give one letter or whole universe length string to it, the output size will be of a fixed length string. So the properties of hashes are, it is deterministic. Every time you give a same string, the output will be the same. Output will not change. The second thing is it is quick, it is order 1. And third thing is, given hashes, you cannot determine the string from which it came from. This is quite obvious because the number of strings are infinite, whereas the number of hashes are finite because the size is fixed. So that's why they are infeasible to determine. Now they are unpredictable. What do I mean by it? I will show this by an example. I will write. No, that's not what I wanted to say. They are unpredictable. I mean by this that this is a PyData Meetup. Okay, I have written this statement. Now let's calculate hash of it. Okay, so this gives me a hash. So this is the hash of this is a PyData Meetup line. Now let's copy the hash and paste it here just to check and match it with another sentence. I just put a full stop after the end of the sentence. This is a PyData Meetup dot. So now if I calculate the hash, this is my new hash. Now you will not see any similarity between this hash and the previous calculated hash, whereas I have just only inserted a dot. And there is no similarity between this and this, so it is completely unpredictable. So this is what Yeah. Yeah, it's one-way function. It's irreversible, that's what I mean. Yeah. So there is no similarity except the lengths are same. So this is what hashes are. Yeah, so now there is a library in Python for hashes. You can directly import hash and calculate anything. So in cryptography, normally in Bitcoin, we use SHA-256, which is a 256-bit hexadecimal output. That's the constant length we use. So how blockchain uses hash? So basically you are given a number. So there is any transaction, write the transaction as a string, calculate the hash of it, and you have to add a number so that the final hash, when you calculate by concatenating these two strings, starts with 3 zeros. The final hash should start with 3 zeros. So calculation of this number can be done only through brute force method because hashes are unpredictable. So this number is calculated only through brute force method. And suppose you increase number 1 by 1, you start with 1, 2, 3, and by applying a number 21191, you concatenate these two, and you finally get a hash which has 3 zeros in starting. So this is the number which you wanted for. We call this process as mining. This calculation of hash from a hash and concatenating it to produce an output such that this starts from 3 zeros is called mining. So, and the people who do it are miners. So this number also is a proof that some work has been done upon to produce this number. This number requires some computational powers to calculate. So that's why this is called proof of work, because some work has been done and this is a proof that work has been done. So that's why the Satoshi Nakamoto paper is termed as proof of work. This number in blockchain terms is called nonce. This number calculated is called nonce. And this is the simple proof of work thing. You can see that I'm only applying brute force method, increasing nonce by 1 every time to calculate the final output. Now, mining is hard because it requires huge amount of computational powers. But verifying after the nonce has been calculated is very easy because hashes are O1. You can calculate hash very fast. Now, mining Bitcoin consumes currently 30 terawatt hours of power globally, which is higher than the individual energy uses of 159 countries. This is how big the computational power is used in mining. So this is only for Bitcoin. There are 1,800 cryptocurrencies out there, more than that. So for the proof, it's very easy. We just have to check if the string starts with the number of zeros, what we predicted. If we decrease the number of zeros, suppose we write only 1 zeros is required. Here I've written that I need 3 zeros of the final hash. If I write only 1 zeros, then the probability increases and mining becomes easier. So this is how I validate the final product. So what a block contains in a blockchain? A block contains a block number, a nonce, the data, hash of the previous block, and hash of all of these things. We concatenate them and make them in a chain. So this is what a blockchain contains: block, transaction, nonce, previous hash. So what we do is that we give the previous hash of the block as an input to the next block. And then we calculate hash of this block, and then we give this hash as an input to the next block. So this makes a chain. And if you change any one of block, then any block preceding it will change, because this is all of them are constructed together. So this depends on all the previous blocks. This depends on all its previous blocks. So if you change any one block, all the block preceding it will change. So that's how we construct a block with a chain. That's why it is called a blockchain. And thank you. So I will show you one application of blockchain. This is on Python, and basically I do a transaction. You have to take a public key and a private key. So I generated the public key is given here. The private key is given here. This is sender's private key. You don't have to disclose it to any other thing, any other person. And recipient address. So recipient's public key. That's what they mean by recipient's address. So this goes here, and the amount, suppose 500. So I generate a transaction, okay, and then this transaction goes to all the miners. This transaction has came here. I have to mine the block, and after mining it will be added in the blockchain. So after mining, that transaction is added in the blockchain.